This is Chapter 5.2, Exercise 9. This section 5.2 in the book has to do with verifying trigonometric identities. In this case, we have problem 9. Cosine theta over 1 plus sine theta plus tangent theta equals secant theta. What we're going to use is trigonometric identities to take this left side of the equation, left side of the identity, to manipulate these terms and get that left side to equal the right side. And I find these helpful in that sometimes if you're given an expression like the one on the left side, you don't know where you're going to end up a lot of times. You'll be told to simplify, but not how. Well, when you have an identity where you have a target of secant theta on the right, so it gives you an idea of what to do. The thing that I find helps the most in a situation like this where you don't have a squared, if you have a cosine squared theta or tangent squared theta, a lot of times you can use the Pythagorean identities. But in this case, you're going to look on the left side and change everything to sine and cosine. Well, the only thing on the left side that's not in terms of sine and cosine is this tangent. And for that, there's a quotient identity, what they call a quotient identity, which is this. The tangent theta, tangent angle we call theta, is equal to the sine of that angle over the cosine of that angle. So we're going to go ahead and substitute and work on the left side to get it equal to the right side, we hope. And so the left term here, we have cosine theta over 1 plus sine theta, so that just stays the same. But it's this next term right here, tangent theta, that we're going to substitute in sine theta over cosine theta. And then we're going to eventually equal, we hope, get the left side to equal the right side. What we have here with these two terms is an uncommon denominator. So what we're going to do is create a common denominator by multiplying these two together. And I'm going to work this out. I'm going to rewrite first cosine theta over 1 plus sine theta. And in the denominator, this 1 plus sine theta, I'm going to wrap in parentheses for a reason I'm going to show you right away. What we're going to do to create a common denominator, we're going to multiply these denominators together. In order to do that, for this first term, we're going to multiply this by cosine theta over cosine theta. Now, do you realize when we multiply by cosine theta over cosine theta, we have not changed the integrity of this cosine theta over 1 plus sine theta, right? And then for this term here, this sine theta, we're going to have sine theta over cosine theta. And then we're going to multiply that by this 1 plus sine theta over 1 plus sine theta. And then I'm going to also wrap these, the numerator and denominator, in parentheses. And so what we've done is we're in the process of creating this common denominator. And now let's multiply the numerators together on this left term. We're going to have cosine squared theta, which is cosine theta times cosine theta, over our common denominator, which is quantity 1 plus sine theta times cosine theta. And then this other term here, we have plus, and what I'm going to do is multiply the sine theta times 1, which is sine squared theta, and then sine theta, sine theta times 1. That's just going to be sine theta. And then plus sine theta times sine theta, which is sine squared theta. And that's all going to be over the one we had earlier, which is cosine theta times 1 plus sine theta. And now we're going to write these over a single denominator. So we have sine theta I'm going to write them in order. We have cosine squared theta plus sine theta plus sine squared theta all over 1 plus sine theta times cosine theta. Now, we have in the numerator cosine squared theta plus sine squared theta. Well, cosine squared theta plus sine squared theta, I hope you recognize that as Pythagorean identity is equal to 1. So what we're going to do is move this up here to the right. We have cosine squared theta plus sine squared theta equals 1. So we have 1 plus, and this 1, again, is replacing this cosine squared theta plus the sine squared theta. And we have left over in the numerator this sine theta. And in the denominator, we have quantity 1 plus sine theta times cosine theta. And I hope you can see that now we can enact a cancellation of 1 plus sine theta in the numerator over 1 plus sine theta in the denominator. And so we have left 1 over cosine theta. And then 1 over cosine theta is, from reciprocal identity, is equal to secant theta. And so that squares with our original secant theta here. I'm drawing this red arrow here. See that red arrow? And I'm going to write secant theta here on the right side. Check. So the steps are shown here. Not the simplest problem in the world, but one that step by step I hope you're able to understand and go through the similar problems. Thanks for viewing.